Hello my students, in this video we are going to focus on derivatives of inverse trigonometric functions. So we are going to learn how to differentiate the inverse trigonometric functions. First, if we have arc sine, or we can say sine inverse of x, we have a function of sine inverse of x, inverse trigonometric function of sine, or we can say arc sine of x. So the first derivative of sine inverse of x, it will be 1 over square root of 1 minus x squared. 1 over square root of 1 minus x squared. And if we have the function of cosine inverse of x, the first derivative of cosine inverse of x, like sine inverse of x, but we have at the top we have negative 1 over the square root negative 1 over square root of 1 minus x squared. So sine inverse of x, the first derivative of sine inverse of x will be 1 over square root of 1 minus x squared. But cosine inverse of x will be negative 1 over square root of 1 minus x squared. And the first derivative of tan inverse of x will be 1 over 1 plus x squared. Or we can say 1 over x squared plus 1. The differentiation of cotan inverse of x, it will be negative 1 over 1 plus x squared. Like tan inverse, but we have negative 1 in the top. And the first derivative of sec inverse of x will be 1 over absolute value of x times the square root of x squared minus 1. 1 over absolute value of x times square root of x squared minus 1. And the first derivative of cosec inverse x, the same as sec inverse, but we have negative 1 at the top and then the same bottom. Negative 1 over absolute value of x times square root of x squared minus 1. So we can deduce that sine inverse of x and cosine inverse of x, the same derivatives, but we have negative 1 at the top in cosine inverse of x. And tan inverse of x, like cotan inverse of x, but we have negative 1. Sec inverse of x, like cosec inverse of x, but we have the equivalent derivative, but we have negative 1 at the top. So the first derivative of sine inverse of x, or arc sine of x, it will be 1 over square root of 1 minus x squared. And the first derivative of cosine inverse of x, it will be negative 1 over square root of 1 minus x squared. And the first derivative of tan inverse of x, or we can say arc tan, it's gonna be 1 over 1 plus x squared. And the first derivative of cotan inverse of x will be negative 1 over 1 plus x squared. and the differentiation of sec inverse of x is equal to 1 over absolute value of x times the square root of x squared minus 1, and the first derivative of cosec inverse of x will be negative 1 over absolute value of x times the square root of x squared minus 1. But if we have an inside function here, like u, if u is a differentiable function with respect to x, if u is differentiable function with respect to x, so easily we can say sine inverse, the first derivative of sine inverse of u or f of x is equal to 1 over square root of 1 minus, we are going to replace x by u, so it will be u squared, but don't forget, times du by dx, times du by dx, or y prime, the first derivative of u prime, the first derivative of the inside function u, like the derivatives of composite functions. Cosine inverse u, the first derivative of cosine inverse u, where u is a differentiable function with respect to x, will be negative 1 over square root of 1 minus u squared times u prime, or we can say du by dx. And the first derivative of tan inverse u, so we are going to replace x by u, so it will be 1 over 1 plus u squared times u prime. And the first derivative of cotan inverse u, the same, but we have here u squared times u prime, or du by dx. And the first derivative of sec inverse u, it will be 1 over absolute value of u, absolute value, the absolute value of the inside function u, times square root of u squared minus 1, and don't forget, times u prime, the first derivative of the inside function. And the first derivative of cosec inverse u, it will be negative 1 over absolute value of u times square root of u squared minus 1 times du by dx, multiplied by the first derivative of the inside function. Let's see some examples. Let's see example 1. We need to find dy by dx. If we have f of x is equal to sine inverse x all to the power 2, all squared, sine inverse x all to the power 2. So here we have a composite function, so we have to use the chain rule. Then remember that the first derivative of the composite functions, if we have f of g of x, the first derivative of f of g of x, it will be the derivative of f times the first derivative of the inside function g prime of x. F prime g of x times g prime of x. Then f prime of x, according to this rule, so we are going to apply the chain rule. So it will be 2 times the same function all to the power 2 minus 1, which is 1, times the first derivative of the inside function, which is sine inverse of x. And we know that the first derivative of sine inverse of x will be 1 over square root of 1 minus x squared times 1 over square root of 1 minus x squared times 1 times dx by dx times 1. So we can say f prime of x we can simplify this expression. It will be 2 sine inverse of x over square root of 1 minus x squared. And this is the final answer. Let's see another example, example 2. If we have f of x is equal to 3 cosine inverse x all to the power 4, and we need to find dy by dx, or f prime of x. Again we have composite functions, so we are going to use the chain rule. Then f prime of x, the first derivative of this function, it will be 4 times 3, it will be 12 cosine inverse of x power 4 minus 1 power 3 times the first derivative of the inside function will be negative 1 over square root of 1 minus x squared, because the first derivative of cosine inverse of x will be negative 1 over square root of 1 minus x squared. And we can simplify. It will be negative 12 cosine inverse of x all cubed over square root of 1 minus x squared. This is the final answer. Example 3. If we have a function of y is equal to x tan inverse x plus tan x all power -1. And we need to find dy by dx. But first we have to know that we can solve this term by the power rule, or we can convert it to cotan x, because we have to know that tan x all power -1 like x power -1. So it will be 1 over tan x. And we know that 1 over tan x is equal to cotan x. So we can convert tan x all power -1 to cotan x. But if we leave it as it is, we are going to use the chain rule. So it's your choice. In the first term, we have a product of two functions, x times tan inverse of x. So we can call x u, and tan inverse of x we can call it v. Then we need to find y prime and v prime, and then we can apply the product rule. U prime, the first derivative of x with respect to x, will be 1. Sorry. The first derivative of tan inverse of x, it will be 1 over 1 plus x squared. 1 over 1 plus x squared. Then we can apply the product rule for the first term. Then y prime is equal to u prime v. U prime v plus uv prime. U prime is equal to 1 times v times tan inverse of x. So it will be tan inverse of x plus uv prime, x times 1 over 1 plus x squared. X times, we can say x over 1 plus x squared, plus the second term, tan x power -1. So we are going to apply the chain rule. So it will be -1 times tan x power -2 times, don't forget, the derivative of the inside function. So it will be sec squared x, the first derivative of tan x, sec squared x. Then we can simplify this expression. Y prime is equal to tan inverse x plus x over 1 plus x squared minus negative tan x whole power -2 times sec squared x. Then we have to know that tan x power -2 is equal to 1 over tan squared x. And we can replace 1 over tan squared x by cotan squared x. So y prime is equal to tan inverse x plus x over 1 plus x squared minus cotan squared x sec squared x. And this is the final answer. Example 4. If we need to find the first derivative of sine inverse of 5x. Here we don't have x, we have 5x. So we can call 5x u. So we are going to use the chain rule because we have composite functions. U prime is equal to 5. Then dy by dx is equal to the first derivative of sine inverse. It will be 1 over square root of 1 minus x squared. And don't forget, we have 5x, not x, so it will be 5x all squared. Times u prime. We have to remember that dy by dx, the composite function, we have sine inverse u, so it will be 1 over square root of 1 minus u squared times u prime. So it will be 5. Then we can simplify. Dy by dx is equal to 5 over square root of 1 minus 5 squared, 25x squared. And this is the final answer. Example 5. If we need to differentiate f of x, which is equal to sec inverse 1 plus x squared. And we know that the first derivative of sec inverse u, we'll use differential function with respect to x. It will be 1 over absolute value of u times square root of u squared minus 1 times the first derivative of u prime. Or we can say the inside function, because we have a composite function. So again, we are going to use the chain rule. Then f prime of x is equal to the first derivative of sec inverse, which is 1 over absolute value of the angle, which is 1 sorry, Sorry, see you tomorrow.